Okay, hello guys. So I'm just gonna go over questions 5, 6, and 7 on the PS2. So we're gonna start off with 5. The question asks, the concentration of an inhibitor is 183 picomolars. And so this chart right here will be given to you. It's just that you will have to calculate these numbers and take the inverse of them and put them in this little chart here to make the Lin-Weaver-Burk plot. So because the Lin-Weaver-Burk plot is a double reciprocal of the Michaelis-Menten. So you have to make a Lin-Weaver-Burk plot showing both the non-inhibited and the inhibited reactions. Your Lin-Weaver-Burk plot should have labeled axis with units. So the graph should display both the y-intercept and the x-intercept and include linear trendline equations. So here, so here we have the Lin-Weaver-Burk plot that I made. And so these are the equations. And this one is going to be with the inhibitor, and this one is going to be without the inhibitor. And so basically, I figured out my little x-intercept and my y-intercept. You can look at it by looking at the graph, and the y-intercept is here as well. And this is our slope. And so that is about it. And then for 5B, let's see. Okay, so determine the Vmax for the enzyme in the uninhibited state and make sure to include units. So the Vmax is given by the y-intercept of the Lin-Weaver-Burk plot. Since the y-intercept of the plot is actually 1 over Vmax, you must set 1 over Vmax equal to 5.2434, which is where the uninhibited line crosses the y-intercept, and solve for Vmax. So we're going to look at the uninhibited line, which means the one without the inhibitor. So see. It's this one. So this one is going to be without the inhibitor. So our y-intercept is 5.2434. But remember, our y plot is 1 over v, so it's the inverse, correct? So we're trying to find the Vmax itself. That's why we have to take the inverse of this. So basically just do simple algebra. Okay, so do simple algebra, and so you do 1 over Vmax equals to 5.2434, and then you just do 1 and take the inverse of this, the y-intercept that you got from the Lin-Weaver-Burk plot, and you get the Vmax is equal to 0.1907 micromolar per second. Okay, and then I'm gonna do 5C. Okay, so for 5C, it says determine the Km for the enzyme in the uninhibited state and determine the type of inhibition for this inhibitor PA and briefly explain. So the slope is equal to Km over Vmax on the Lin-Weaver-Burk plot. Therefore, 1.7388 equals to Km divided by 0.1907, thus giving a Km of 0.3316 micromolar. So basically the 0.1907 we have figured out, I believe, in the previous problem. It was our Vmax for 5B and for the uninhibited line. And then 1.7388 is what we get for the slope here. And so for our uninhibited line once again. And so basically you do 1.7388, which is our slope, equals to Km divided by Vmax. We don't know what our Km is. So what you do is basically like the 5A, you just do 1.7388 and divide by Vmax to get the Km. So it's going to give us a Km of 0.3316 micromolar. By looking at the graph, we are able to see that both the Vmax and Km decrease, and the slope stays the same. This is a characteristic of the uncompetitive inhibitors Lin-Weaver-Burk plots. Thus, the inhibitor is uncompetitive. So if you guys remember from the sheet I gave you, I emailed you, we can tell that our graph matches up with this uncompetitive inhibition graph. And so just remember that I said this in class, was that with the inhibitor, it's usually going to be like the line is going to be higher than the one without the inhibitor, or it's going to be steeper. This is because usually the Vmax in this case is going to be reduced. So the higher the Vmax on here, the lower it is, the lower the Vmax value, since it's inverse, if that makes sense. Email me if it doesn't. And then we're gonna move on to 5D. So it says calculate the Ki for the inhibitor. So you have to know for an uncompetitive inhibitor, in order to find the Ki, you must use this equation. And so what I did was I did Vmax approximation equals to 1 divided by 11.758 equals to 0.08505 micromolar per second. So this is kind of like just figuring out the Vmax, the first step. So this is kind of like 5B, I believe, how we figured the Vmax out, but this is with the inhibitor line. So we know that 11.758 is our y-intercept for the inhibited line on the Lin-Weaver-Burk plot. So then we have to plug in the concentration of our inhibitor, which is 183 picometers, and just convert it into micromolar, which is times 10 to the negative fourth. And remember, micromolar, like 1 molar is times 1 times 10 to the negative 6 micromolar. And so 1 picomolar is 1 times 10 to the negative 12 picomolar, sorry. So it's just a unit conversion. And then I will flip to 5D, continue this 5D question. So I'm going to do 0.08505 equals to 0.1907 divided by 1 plus 1.83 times 10 to the negative fourth divided by Ki. So basically this is just me plugging in numbers into the equation that I had posted starred at the beginning of 5D. So basically it's 1 plus 1.83 times 10 to the negative fourth over Ki equals to 0.1907 divided by 0.08505. Essentially, I'm trying to basically isolate Ki, and the 0.08505, as you can see here, is a Vmax with the inhibitor, and the 0.1907 is the Vmax without the inhibitor, which I figured out in the previous problems. So I do 2.2421, whatever this is, minus 1 equals to 1.83 times 10 to the negative fourth over Ki, and 1.83 times 10 to the negative fourth is just a concentration of the inhibitor. And then I divide this and I get the Ki equal to 1.47 times 10 to the negative fourth micromolar for 5D. So that is it. And then I'm going to do question 6. So 6A is asking what kind of inhibition is seen in the first plot and how do you know this? So we're going to look at our first plot first. So our first plot is here. I hope you guys can see that clearly. So our first plot is here. And so this is the orange line. And as you know, as I said before, that this is going to be the inhibitor line and this is going to be the non-inhibited line because it's lower and this one is higher. And usually the slope is steeper for the ones that are inhibited. So let's see. Close these out. So 6A, the plot shows pure non-competitive inhibition. In pure non-competitive inhibition, inhibitors have equal affinity for the free enzyme and the enzyme substrate complex. Additionally, the binding of the inhibitor to the ES complex does not influence the binding of the substrate to the ES complex. This means that Km is unchanged, hence the steeper slope of the orange line compared to the other and the more positive or larger y-intercept of the red line. So y-intercept is 1 over Vmax. So for this one, just kind of had this memorized, the little sheet that I gave in order to understand how these the inhibitor and non-inhibitor lines compare to each other and how their Km and Vmax values change. And so this one was uncompetitive. So what I said in class also was that for our graph here, it looks like it's competitive because it's crossing, but don't look at this, ignore this. Just look from the x-intercept here to above. And so this is just non-competitive, as we can see in our graph here. Okay. And so for 6b, so what kind of inhibition is shown in the second plot? How do you know this? The plot shows competitive inhibition. Let me show you the second plot really fast. So the second plot is here. Remember I said just ignore this part and look above the x-intercept. So you see that it crosses here on the y-intercept, and that matches our little graph here, competitive inhibitor graph. And so, okay, so for 6b, the plot shows competitive inhibition. Competitive inhibitors compete with the substrate for the active binding site of the enzyme. Vmax is unaffected as seen in the identical y-intercepts, which equal to 1 over Vmax. Since maximal enzyme efficiency could still be reached if enough substrate were added, slope is steeper in one line compared to the other, m equals to Km over Vmax. Since there will be more free substrate leading to an increased Km, which is basically around K-1 over K1. So more free substrate will lead to higher Km and the steeper slope. And then C6C. Let me X this out really fast. Okay. So in the first plot, which line represents the inhibitor and why? What is the Vmax of the enzyme in the second plot, and use molar over second? So in the first plot, the orange line represents the enzyme with the inhibitor. And so I'll just show you that this is the orange line. Remember, it's steeper and it's higher for a non-competitive graph, and so it's going to be the inhibited line. So in the first plot, the orange line represents the enzyme with inhibitor. Since adding a pure non-competitive inhibitor decreases the Vmax, the y-intercept of the inhibitor line will be greater. Also, the slope will be steeper. And for the second plot, y-intercept point will be 1 over Vmax. And the 1 over Vmax will equal to 5. And so just how we did the other Vmaxes when figuring out through the Lin-Weaver-Burk plot is we just do 1 divided by 5, take the inverse of the y-intercept, and equals to Vmax, which is 0.2 molar per second. And so someone asked in class what the 5 was, and so this is basically, where is it? So for my competitive for the first plot, the non-competitive inhibitor graph, this one, the second plot, it's going to be this. It's going to be the y-intercept. So this is where we get the 5 from. And we just take the inverse of this because it's 1 over v, not for the y plot. And this one is competitive inhibition. Okay, so I'm going to move on to 7. Pretty short. Okay, so for each of the following, identify whether they are a coenzyme, cofactor, apoenzyme, holoenzyme, or none. Explain why you chose each answer. So the heme is a coenzyme in various proteins, including hemoglobin, involved in oxygen transport. And then cytochrome C is a holoenzyme involved in shuttling electron in the mitochondria, which contains a heme prosthetic group. And ascorbic acid is a coenzyme. It is an organic molecule that's a non-protein. And then iron is a cofactor needed to make a hemoglobin and myoglobin. So basically just know the overall concept of coenzyme, cofactor, apoenzyme, and holoenzyme. Coenzyme basically helps the enzyme function. Cofactor makes something, as you can see in the iron. And then the apoenzyme is without the prosthetic group. So essentially the prosthetic group helps to function. And then the holoenzyme is with the prosthetic group, as we can see in B, I believe. So that includes the prosthetic group, which helps the enzyme to function. And so apoenzyme is without the prosthetic group, and holoenzyme is with the prosthetic group, which essentially helps to function. So kind of know the basic meaning of these 4 terms for the exam. And I believe that is it. Also, coenzyme is an organic element. It could be like vitamins. So ascorbic acid is also known as vitamin C. And then a cofactor is like dietary elements like iron, and they're inorganic materials. And they're both really small, cofactors and enzymes, coenzymes. And I believe that is it. Let me know if you guys have any questions, and I'm going to end the recording now.